All right, here's part 2 of the video. I want to talk to you about question 3 a little bit. Starting with 3b, if the ratio of the two similar triangles is 3 to 5, then the ratio of their areas is going to be 3 squared to 5 squared, or 9 to 25. That's how it works, because if you're going to do something to two different dimensions, like a base and a height, then you're doing it sort of in a squared fashion, because if you're multiplying something by 2, let's say, then you would have base times 2 and height times 2, so the overall effect would be times 2 times 2, which would actually end up being times 4, or 2 squared. And so when we're dealing with area, we always square the ratio. So for question 3b, let me just pull it up here on my screen. The area of the larger triangle is going to correspond to the ratio that we just came up with. So if the area of the small triangle is 36, then the area of the larger triangle is our unknown. And if we use our Z pattern here, we're going to do 25 times x divided by 9. So x equals 25 times 36 divided by 9. And so whatever x is our answer there. Okay? So for question 3c, for this guy here, then we've got the triangle. You worked out the triangle side length 16, and the other one is 6. So what we have is a ratio of 6 to 16. But when we're looking at the areas, we want to square those values. So we end up with 36 over 196, and that will reduce to lower terms, I believe. So the question asks, what's the ratio of the areas of the largest triangle to the smaller triangle? So largest to smallest would mean that we have to flip that and write it in that way. And again, I think that both of these values will divide by 4. I think so. I think you'll get 49 on top and 9 on the bottom. So if you want to go to lowest terms, you can go to 49 over 9. But the big idea here is being able to write the ratio of the areas as the ratio of the squares of the side ratios. Okay? So here we are with the last 2 questions on this assignment, 4 and 5. And you handled the ratios well, and you actually solved for the unknown really well. One of the things that I wanted to point out for you in number 5 is that most people actually miss the fact that 3.6 is actually the length of this side. They forget to add those two values together to get the length of the full side. One thing that's helpful is to pull out the 2 triangles and draw them as separate triangles with their dimensions written on there separately. It just helps to visualize the whole problem. But you've got that all sorted out in terms of your ratios and your proportion here that you're solving. So you did a great job. The only thing that you have to include that you haven't got here is that in question 4 and question 5, if I'm not mistaken, there's no information given in either of those questions where you're told that those 2 triangles are similar. So the first step always with word problems like this is to first prove that you have similar triangles, and that's why each one of these is worth 5 marks, because there's more work than just a ratio to solve. For question 4, we need to have right angle triangles here, because if you don't have the vertical at 90 degrees to the horizontal, you're going to end up with something that falls down. So we know that that's true. The other part here that we need to consider is that it's the same time of day. We would have the sun shining and creating this shadow at exactly the same time of day, which means that the sun's shining at exactly the same angle. So that makes this angle and this angle, if you want to use a technical description for it, it's the angle of depression of the sun's rays with the ground. But all we care about is that this angle and this angle are equal because of the same time of day. So you need to start, in both cases, for 4 and 5, you need to start with, angle, whatever you want to call this one, equals angle, whatever you want to call this one. Angle this one equals angle this one. Therefore, we have angle-angle similarity. Therefore, now we can do a ratio and we can solve for x, okay? So same thing over here for number 5. If you draw in your right angles, you've got one pair of equal angles, and in this case, this angle down here is a shared angle because both triangles have the same angle as part of them. So again, you've got angle-angle similarity, which you must write out, angle given, angle common, and then you can say, therefore, this ratio has to be true, and now I can solve for the answers. So you have the right answers, but unfortunately didn't include really the most important part of the solution, which is the proof that you have similar triangles there. So I hope that helps, and please email me if you have any more questions. We'll get you sorted out on the triangles problems, okay?